Have you been looking for a way to stay focused on your goals and grow your MSP? Accountability groups from RocketMSP can help. We offer weekly accountability sessions that meet online with a group of your peers. Your success begins with accountability. Go to www.rocketmsp.io to join your accountability group today. We talked about some stuff that made my brain hurt, not going to lie. And you were able to simplify it for me and basically explain that, SD-WAN allows you to control things at I'll call it the data center that's not your office. So it comes into that place, wherever the data center is, that does whatever you ask the network equipment to do, and then it sends it to my office or home over my internet connection or connections. Mm-hmm. And I believe you also said that SD-WAN originally, or is supposed to be, or whatever, designed so you can take 2 or more internet connections and bond them. So that way, if you've got me, I'm lucky. I've got a gigabit connection here right where I'm at. So what you're saying is I could get 5 of these gigabit connections.
Yes.
Bond them all together using an SD-WAN and now have 5 gigabit internet.
Essentially, the only thing I would caution on using the concept of 5 gigabit is just like Amazon services. If you do threshold testing, a lot of them can't exceed a gigabit per second. They just don't expect the consumers of that to be getting more than a gigabit per second of a stream anyway. So I know that we've done tests with cloud access product that are 3 gig, I think, but when you start getting into 5 gig, I would ask the question, what is it you're trying to do with 5 gig of throughput?
Don't tell me how to live my life, Rob. Just let me live the fantasy.
Hey, I'll just pick the right tool to make it happen. That's the difference. So,
all right. So, so I should not have a 5 gigabit connection. But what you're saying is, if I had 5 10 meg connections,
yes,
then I could have a 50 meg connection essentially by bonding
500 meg,
together.
500 meg, absolutely.
Then why not 5 gig connections?
The only reason I caution people on gig is that we've run into issues even just in the last month here, like I said, with Amazon, where someone had their data center services in the same data center as some partner they were connecting to their application. Mm-hmm. And there was a gigabit threshold between the hypervisors and the technology that Amazon uses in the data center. So even though it's 1 millisecond response times, they had a 1 gig bottleneck. So when we start exceeding that 1 gig bottleneck, I just start to make sure everybody understands, there's technically, you're just moving the bottleneck at that point. There's still restrictions. So,
well, I think the obvious answer is, what do I want a 5 gigabit Ethernet connection for? I mean, like you said earlier, we don't want to use BitTorrents. It's because news groups are better.
Hey, absolutely. And where I would go with this conversation is, like, let's just say in a closed lab environment, you had server, let's say it's an SMB server, something simple, port 445. You've got your SMB client on the same network. Let's even say it's a 10 gig network, just so that you've got,
already.
Let's see what this thing can do. Even if the process and the hardware you've got, you beef that up and you max it out, how fast or how long does it take for that SMB traffic to consume 1 gigabit per second? I challenge anyone listening to this to, do that experiment. And what you'll see is there's a slow start kind of graph, and it's not just a, 1 gig. It takes a second to get to that level of throughput.
Sure.
You might have it available, but now you're talking about limitations of TCP. And this is where Replify comes in. Time to first byte is a metric that on any web page, you can right click in Chrome and inspect element, and then you can refresh the page that you're on. And it doesn't matter if it's news sites are great. I'm not going to pick one for, staying out of, left, right leanings, pick a third party country, BBC.
iPhone or Android.
Doesn't matter, whichever one you prefer. But inspect element and look at that waterfall. You're going to see at least 100 to 200 different HTTP GET requests. And the time to first byte, you'll see this, and this would be a great demo someday just to show the problem, because I've been really surprised to learn how many MSPs really have never dove that deep into analyzing the tools they're working with. So something's slow, they have the option right there in Chrome to really see what part of it is slow. Some of them are using outdated DNS. It's just, you can see how long does it take for this one request out of that 200. How long does it take for the DNS response? How long does it take for time to first byte? How long does it take for delivering the actual payload? And when you really start to look at that stuff, you get a deeper understanding of what it is the real problem is that you're trying to solve. And with, a dentist type of setup where they've got this application, they got a couple of branch offices that are all connecting to it. They don't really have bad latency, but it was designed to work in a LAN environment, which is still sub, 10 milliseconds, not 50 and 100 milliseconds. When you start working in those types of environments, you really start to see the value of Replify, where they do TCP enhancement, like we started to talk about TCP BBR, or time to first byte enhancements, optimizing things at layer 3 and above, or layer 4 and above. Even getting HTTP specific protocol optimizations. So instead of having to wait for this back and forth three-way handshake, if you've ever done a Wireshark capture, you can see that ladder diagram. That would be another great tool to do, where we can actually see the back and forth before you can even transfer byte number 1. Let's say it's just a 1K payload. The time to send that is huge. That's the type of thing that WAN optimization addresses. So you can go from this curve to saturate that link significantly quicker.
All right. So I just shared my screen a moment ago. I'm gonna put it back up here in just a moment. So I'm not a Chrome user. I'm a Safari user.
Okay.
Because I don't know, because I like being that guy maybe.
Yeah.
So if I look at this website, that full disclosure, I designed this website. Okay. If I'm looking at this correctly, JavaScript and events is happening before the 60 millisecond mark, or the 70. I don't know which one is which, but so you just said that the newer websites are super not great.
Well, no, so to clarify, if it depends on your hosting provider. If they've enabled HTTP2, for instance, then you're doing some things at the server level, like TCP multiplexing, which is something we've been doing in WAN optimization for a while. And we do that for things that don't natively support it. So websites may not be the best application here to talk about that problem with, but just so that you can see the problem, this is the easiest way that everybody on this stream can just right click and see it. And you may not be able to see it that way with, like I said, the dentist application. If it's web-based, then of course you can. But most of like SAP or pick any ERP system, I've still not found one that is HTTP2 where it's trying to overcome some of these problems. And those are the types of applications where WAN optimization would just absolutely help. SMB shares across the internet or VPN. We can talk about why it gets worse over VPN. So it makes it clearer how WAN optimization helps. But just your run-of-the-mill website, those really aren't the problems we're trying to address, even though it does help. That's not our focus. This is just the easiest way to show you the problem.
Gotcha. Okay. That makes better sense, because I was about to yell at you for saying all new websites are slow, and mine isn't, darn it.
No, actually, there's a great tool, and I don't remember the name of it right now, but there's a little Chrome plugin. I don't know if there's one for Safari, but you can enable HTTP2 and Speedy indicator, and it'll show you if the website is HTTP2 compliant, so that you're getting that instead of serial, ping, 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 BB gun type of effect, it's a shotgun effect. And, ask for this and you get, 6 concurrent, HTTP streams multiplexed in the response. So instead of having to wait for that 15K thing before you go on to the next request, DOM load and page load time that's kind of the thing to look at in the bottom of that inspect element section of your browser. We've seen that cut down to 25% of what it is. 9 seconds to load a page down to 3 seconds. So we're not always talking about byte deduplication and benefits offloading bytes as much as we are also time. So, but if you've got HTTP2 on your website, that's great. We still help in that regards. We have HTTP2 support, so we're still doing some things there. But that's just the way to see the problem.
Okay. All right. So let's get back on the train here. The SD-WAN train. Choo choo. All right. So this all still hurts my brain, Rob, but I'm starting to get it. So you said that you work with some of these other vendors. You mentioned Ethica, and you mentioned, I'm going to say Replibit, but I know that's not right.
Replify.
Replify.
Replibit would have actually be very applicable, though. That's a good one.
All right. So so Replibit. Let's talk about Replibit for a second then. Because maybe we should talk about how can this apply in the real world? So Replibit is a backup tool. So we could switch that out for a Datto BDR or Veeam or any other backup software. And let's pretend we're backing up over the cloud.
Sure. That's a perfect use case.
All right. So walk me through this. What do we need and why? Because I want to make sure my backups are fast and never fail.
Right.
At the internet end, I should say.
We had a bank that we worked with in the past that had 10 meg over their MPLS connections, and their backup was still going at 8 something in the morning when people started to get in, which makes people a little nervous, that the network's slow and, the application they're connecting to is slow, sometimes not even available if it's being backed up. And an 8-hour backup job we've seen with Replify reduced to a couple of hours. So, how does that work?
Really?
Absolutely. So there's several different technologies that Replify uses. For one, compression. How do we squeeze 50 meg of stuff into a 5 meg zip file? It's the same basic technology, just applied to the TCP stream. So if we compress that stuff down, we've got enough compute power now, even if it's running on a Windows server directly with the Replify client, not a box in the middle. You're using the resources you've got with this simple application that's installed right there to crunch that down before it ever goes across the wire.
All right. So is this application something that you're providing us or one of your vendors, I should say?
So it depends on the use case. There are some use cases where we can use the stock Replify client, but because we're an aggregator, we can get
maybe better pricing than direct.
Yeah, exactly. We also provide a level of support. They're focused on the OEM market, and a lot of the MSPs I've worked with have a lot more questions. They want a little bit more access to guys that can do pieces for them. Like, to run a Replify environment, you've got to have some Linux expertise. And what my experience has been is most of the MSPs that the gross majority of SMBs rely on, they're Microsoft-centric guys. They're not the guys that are going to be able to troubleshoot Linux. They probably run some things, but they really don't want to manage those sometimes. So we do the heavy lifting there, for them. But there are also cases where, Replify doesn't provide user authentication. So we've got a wrapper application that we've built that can go in front of that to give the ability to user registration and manage the Replify piece as a background service, which also helps with branding. It keeps Replify from having to, branch their code, which leads into an OEM agreement, which is much more expensive. In order to deploy it, we can work with an MSP to manage that as a background service. So if you have an RMM tool like LabTech or half a dozen,
Automate,
Kaspersky could be a big one. Or I'm sorry, not Kaspersky.
Kaseya.
Thank you. The one that hasn't been hacked. Right. Any of those, if you do push button application deployment, we can get the Replify client pushed out that way. So you don't even have to talk to the users and let them know that you've deployed anything. They just notice that it's faster. So the policy configuration, all of that, that's why we're a value-added distributor. We can help you with all that setup without you having to have that expertise.
Now, when we say, hey, Rob, we need this wrapper, we need this, we need that, is this stuff that you're charging us for?
So most of our value-added features are baked in, if you will, where we use our margin to share with our partners. We're channel focused, but if we do have a customer that needs this directly, we will service them, but we will immediately start looking for an MSP in that region, because we want to bring MSPs up to par, to be able to manage this stuff themselves. Don't know if that answered the question there or not, but.
So you don't charge us for the extra stuff that you've written?
Well, it just depends. Like, let's say, for instance, you had a team of Linux guys, you had your own data center. You're going to get something closer to software only pricing, and we make our margin on that. If you need someone helping manage the server running in your cloud, we're going to charge you something for that, but it's just to cover our costs more than it is. We want you to scale. So our pricing is really focused on the per unit stuff. But
so it sounds
let's say you even needed
the pricing
to offer it as a service, we can do that too. But we prefer to help you grow it if you want to. But it really depends. There's a big range of MSPs out there. So, some of them are even, lone wolves that, they really don't need a lot of help. But at the same time, they just want to manage it. They don't want to brand it. Their brand is them, their time, and the ability to find the solutions. Some people want to be able to monetize this in a different way to compete with MPLS. So it's not unfortunately
it's not
packaged up thing, but we go through probably a 15-minute call, 30-minute call, and we can figure out pretty quick which model fits you best to get you, what you need.
Okay.
And that's something you're never going to find with most of the ISPs. They're selling it. It's a packaged product. It's a fixed price. And, you're looking at hundreds of dollars a month a lot of times for, something that you don't need half of.
So you mentioned MPLS. Let's talk about that for a moment. It has been a long time for me, my friend. So refresh my memory. Let me know if I'm wrong. MPLS is when you just want a connection from one site to another, and you don't need an internet connection. Well, it's going over the internet, but site A is like we'll call it the master or whatever you want to call it. And then site B, their internet connection, because it's MPLS, they can't see the whole internet. They can only see site A. And then if they want, they can set it so that they can get to the internet through site A's internet.
Essentially. So the private subnetting is offered to you by the ISP. So you have a point-to-point circuit, if you will, that they are managing. And what a lot of people don't realize that, I've gotten a lot of confusion on the fact that, my MPLS network is much more secure because it's not on the public internet. Well, that's
it is
mostly true if you think about just the fact that people can't, see that private subnet traffic except for your ISP. And what a lot of people don't realize is a lot of ISPs now are scanning that traffic because it's not actually encapsulated and secured. It's just a private label, and they can see it plain as day in their equipment. So,
and when you say they can see it plain as day, walk me through that. So, like, they can see I'm playing Call of Duty and I just got the new high score, or they can just see that I'm connecting to callofduty.com over port X. They know port X is the port typically used for online multiplayer gaming, and that they can tell I'm connected to the game, but they couldn't tell me I just won.
Yeah, let's use VoIP as a specific example. It's non-encrypted by default. So, I'm actually BroadSoft certified. So I've been through that. Worked with a company years ago. Built a provisioning system. Polycom 501s. That era, and that traffic between the phone and the data center where that's being hosted out of, it's not encrypted. Not the signaling is not encrypted. So the phone number information, the caller information, the signaling, that's not encrypted. Likewise, the payload is not encrypted. So if you're using G.711 or G.729 as the codec, which you're not necessarily choosing, the provider is providing it for you, even if you've done a slider to make it better for your bandwidth, that's not encrypted. So whoever is in the middle is doing very often analysis on that. Even if they're just capturing the signaling data, port 5060, they can see traffic information. We used to do this all the time. Some of it's regulated that they have to. So there's some people that have a privacy concern about that issue. And there's some people that have just a, personal issue with it, I guess. This is why you see kind of an uptick in VPN usage in general, where at least this ISP that I don't trust or this country of origin that I don't trust, they can't see it because it's now encrypted. But what if you want to be in control of where the exit point is, like an MSP, where they have their own data center or they have an agreement with OVH, so they can run whatever data center, they can run these services in whatever data center they want and be in control of where that data flows between point A and point B. That data is encrypted, so you can't see that. And on an SD-WAN product, that's great for shielding from your ISP if you have trust issues there. And I've talked to a lot of MSPs that do for various reasons. You have a lot more confidence that that traffic between your CPE and the data center in control of someone you trust is encrypted, just like a VPN. AES 256-bit encrypted or whatever encryption level you want. That's normally a choice. But that's important to a lot of people. And that's something available in the Cloud Access product, the Replify product. Anything that's bookshelfed, you're in control of where it comes out and if it's encrypted or not.
Okay. So I just want to ask a clarifying question. If they can, it's because the payload is unencrypted, does that mean that hypothetically they can listen to our phone call?
I mean, no question. Pull up Wireshark one day. Like I've got a Ubiquity, device at home. I've got a mirror port on one of my switches. There's a lot of different ways that you can get that without being directly on your own laptop. As long as you're in line on the network, most people know how to do a PCAP, PFSense, OpenSense, there's an option. You just go right in there and capture that and then analyze it later in Wireshark. I don't remember the tool, menu exactly off the top of my head, but you can do a ladder diagram to see what all calls did it see traverse the network, and then let me listen to the payload to the point where you can even say, I want to isolate audio in this direction. I want to isolate audio in this direction, or I want to play them both at the same time so I get both sides of the conversation. And this is actually something that you have to do sometimes for debugging. There's something in the network causing problems, with certain calls. Have you ever noticed, you press the buttons as a menu option on some calls and it's not receiving that input. The DTMF signaling isn't being picked up right on the other end. Well, who do you report that to? You can report it to the provider. But what are you going to report? Sometimes it's helpful to say this call at this time had this specific problem, and just having the tools to be able to see that is valuable. But yeah, you can absolutely listen to that if you're in line.
All right. So, an appropriate question. DTMF, I know what DTF stands for, so I can only assume that DTMF is down to mother. It can't be right.
Dial tone multi-frequency, I think, I think is what it stands for. Essentially what it is it's a simulation, if you will, or an emulation of the old school cross section. Like, everybody's familiar with kind of your tic-tac-toe dial pad. Well, there's a frequency for the vertical lines and the horizontal lines, and whatever combination of frequency this is, 2 has a unique DTMF code. This one has one. This one has one. So all of that signaling that you see in the SIP protocol, and it's.
Wait, hold on a second. So really, because I've always known that, all the numbers sound a little different, and I've always known that they have 2 tones happening.
Right.
But you're telling me that 1, 4, and 7 on the phone, since they're all in a vertical row, one of the tones on all of those is all the same.
Well, the tone that we hear is a concatenation or a combination of both tones, the cross section, if you will. But
I'm saying just one of the two. One of the two tones is the same on that vertical line.
Well, one of the two frequencies that make up this single tone.
Okay. And then each of the horizontal lines on the dial pad, each of those has a specific frequency.
Essentially. The old school analog stuff did, but this is all emulated now. And give you an example, something we helped a customer isolate. One was using I don't remember who the SIP provider was, but they were doing in-band DTMF, which is basically where in that audio stream, you would hear it. Okay. Just like me and you talking, beep, it would be part of the audio stream. That's in-band DTMF. And what they were experiencing was every time this person would, talk or get excited, they would hear a beep. And the reality is they were actually vocally talking at the same frequency of that tone, and you would hear the system thought it was a beep. So you'd hear that. You don't see that as much anymore, but that's because people have gone to out of band DTMF, where when you press that button on a digital device, if they are configured to use out of band DTMF, you don't hear it in the audio stream. You see it in the SIP signaling. So, but I think the issue, because this has been a year ago now, it was, we were able to see with the Wireshark capture, which was easier to get to because of the SD-WAN product we were using. We could see that DTMF code and report it. Just made it easier to describe the problem, the time we were having the problem, and it did get fixed.
All right. So I'm going to ask some ridiculous questions, but that's because I still don't understand really the capabilities of this stuff. Okay. So I understand what SD-WAN can do between me and the data center that the other router, network equipment, whatever is at. But if for the MSPs, let's talk about this on the legal side for a minute. For the MSPs that have that paranoid level of security desire, right?
Sure.
So they don't want the ISP or the government or whatever person they think is going to look at the stuff, may actually be looking at the stuff. I have no idea. They don't want them to see the payload anywhere along the way. So does that mean that they need SD-WAN going from each client to wherever those backups are being located?
So what I would say there is, if your phone number is registered in the U.S. and your provider is servicing that with their data center also located in the U.S., at some point, this is under CALEA, CALEA. There's regulation so that we have tools for authorities to look into issues, whether it's a live threat type of issue or a reactive or a recording that they react to later, for archival purposes. Those features, those are going to be available at the provider. If they're using BroadSoft, if they're using Metaswitch, whatever they're doing to offer that endpoint in the data center, they're under regulations. That's going to be there, but you at least want it to be used if they have a warrant, or if they have, you don't want someone in the middle, someone in your neighborhood that may be, spoofing, things that can intercept traffic, those threats, someone that's going through your private data center, if that's a concern for you, those are the places that you can secure. Once it comes out of, let's say you do have a cloud access product in the cloud and it's encrypted end to end. When you come out of that on the other end of the data center, you still got to go through wherever that data center is to the cloud application. So
at that point, it becomes unencrypted.
It's whatever it is. If it was encrypted, fine. If it's not encrypted, like we're talking about here, right between there and there. That's why there's kind of a nuance in, people using a VPN, to these like NordVPN, ExpressVPN.
Yeah,
they have good products. I'm not bashing them, but the reality is, if it's a matter of trust, you're just moving the point of who you're trusting to wherever that data center is located, and you don't know where that data center is located. So wherever it comes out to your cloud application, that's a potential risk. The thing about an MSP is if you can be in control, at least, like let's say you're hosting in your own data center, you've got a half rack of gear, and you're hosting that dentist application. Or maybe you're hosting their PBX, free PBX or something. I've seen guys do that. And then they're putting their phones on site. You can encrypt it between point A and point B to where at least that between their phones and your node in the data center, it's completely secure end to end, no prying eyes in the middle. Kind of like a VPN, but VPNs cause other problems. We can talk about that, if you want. But you're at least in control of end to end, that not being visible and it being reliable. And that's something, again, VPNs don't traditionally do either, is bonding a connection. So bonding and encryption is a unique thing to SD-WAN.
Okay. I feel like this is a good place to wrap up part 2.
Okay.
I have one question I want to get to.
Okay.
Tara asked another. What about companies that went to work from home policies? Is SD-WAN any different than MPLS for data privacy?
Right. Yeah.
Is it an MPLS backbone still fine?
So typically you're not going to see a company invest in an MPLS circuit all the way to the home.
No.
They're typically going to do that branch to branch or branch to headquarters. So you now have this conundrum of how do we get the same quality, if you will, even though you can use SD-WAN to replace MPLS at that level too. How do you extend that to the home so that what they're accessing in that MPLS cloud is secured even over that last mile? And that's something most people think the solution for is a standard VPN. They might set up OpenVPN or Cisco VPN. And the problem there is you have this slinky effect where the TCP traffic going across that VPN, if there's a hiccup on the internet, it takes a second for everything to come back up.
Mm-hmm.
And that problem's exacerbated with VPNs because that VPN has to be up before tunnel traffic can flow through it. And with Replify, for instance, as let's say a VPN alternative, it's encrypted between that Replify client on your machine and wherever that node sits in the data center. So similar to a VPN, it's encrypted end to end, and your application that traverses that is not having to deal with those slinky effects if there's a network hiccup. Session resume. Have you ever been doing a transfer? Mm-hmm. You had a network hiccup and it didn't just pick up where it left off. You had to click restart, and that's
got to be the most frustrating thing.
Absolutely. SMB shares. Just to make it simple, there. You just got to start over. With Replify, it picks up where it left off because it's looking at things at the byte level. So it can see I've already done up to here, and it can pick right back up to the user. They see that they've transferred the whole file again, but if they've already transferred half of it, you're just seeing a little bitty hash go across the wire. So these are tools to extend that MPLS network to a home user or even a traveling user. Like Replify, it doesn't have to be a box set up at home. This could be something you use while you travel. But we can elaborate on that if you're ready for a break there.
Hey, thanks for listening to part 2. Be sure to check back tomorrow for the next episode.